Hello, I am Anshul and this is the most interesting video in geometry. In this video, we'll cut different geometric figures such as triangle, square and hexagon in different ways. And as we cut them, we'll identify some patterns which will help us bring many otherwise lengthy solutions to a matter of seconds. Let's start right away with equilateral triangle. If we join the midpoints of sides, then what we get is 4 smaller equilateral triangles congruent to each other. If the area of smaller triangle is to be calculated, then we can simply divide the area of bigger triangle by 4. Now area of this figure is half of the bigger triangle as it covers 2 smaller triangles out of 4. Now we can also divide the equilateral triangle into 9 smaller equilateral triangles like this. So area of each smaller triangle is 1/9 of the bigger triangle. Now did you notice a regular hexagon formed in between? Yes, 6 equilateral triangles can form a regular hexagon, or we can say a regular hexagon can be divided into 6 equilateral triangles. So a question can be asked as a hexagon is given with an area of 60 square units. Its alternate sides are extended to form a triangle like this. Find the area of this bigger equilateral triangle. Well, our hexagon consists of 6 smaller triangles. So area of one small triangle will be 10 units. Now this bigger triangle consists of 9 small triangles of area 10 units each, summing up the total area to 90 units, right? Next question. An equilateral triangle is cut from its 3 vertices to form a regular hexagon. What is the percentage of area removed? Well, as we can see in this figure, 3 white colored triangles will have to be removed to make this red colored regular hexagon. Basically, 3 triangular parts out of 9 triangular parts are removed. So 3 out of 9, percentage area will be 3 upon 9 into 100. That would be 33.33%. Next question. An incircle is drawn to an equilateral triangle and on the top of it, another circle is drawn touching the 2 sides and the bigger circle. If the radius of a smaller circle is 2 units, find the radius of bigger circle. Again, if we draw all the 9 triangles, we can see that the triangle circumscribing the smaller circle is scaled by 3 times to circumscribe the bigger circle. Look at the smaller triangle and the bigger triangle. Side of bigger triangle are 3 times the side of smaller triangle, as at the edge of bigger triangle there are 3 smaller triangles, right? So side of bigger triangle is 3 times the side of smaller triangle. That means the circle will also be scaled up by 3 times and the radius of bigger circle will also be 3 times of 2. That would be 6 units. We can also divide the triangle into 16 smaller triangles like this. And as you must have guessed by now, further division will be into 25 congruent triangles. Now there is one more way in which we can dissect this triangle. These lines can be medians, altitudes, angle bisectors, perpendicular bisectors, all are same for equilateral triangles. Now we have seen this in earlier videos that all these triangles are of equal areas. Medians divide triangle into smaller triangles of equal area. Now find the area of this shaded region. It is obvious that these lines are medians as they are bisecting the sides. Now area of the triangle will be half times base, that is 10, into height, that is 6. So area is 30 units. Now construct the remaining median. As the lines are medians, these triangles will have equal area. And our shaded region is 2 out of 6 triangles. Area of 6 triangles, 6 small triangles is 30 units. and we have to find area of two smaller triangles, right? That would be 30 upon 6 into 2 square unit. Moving on to circles touching each other externally. Now find the area of region enclosed in between. If all the three circles are of equal radii, then the triangle formed on joining the centers will be equilateral. Let's focus on this triangle and what's inside it. We have to find this area, right, which will be equal to area of the triangle minus area of the three sectors. Now these three sectors have central angle of 60 degrees as they were inside equilateral triangle, right? So they can be rearranged to form a semicircle. And our required area is area of equilateral triangle with side 2 minus area of semicircle with radius 1. So that would be root 3 upon 4 into side square minus pi r square upon 2. This simplifies to root 3 minus pi by 2. Next interesting observation is in a right triangle with semicircle on all three sides. Now let's say these sides are 2a, 2b and 2c. We can apply Pythagoras theorem, right? It's a right triangle. Take out 2 square common and cancel it from both the sides, and we get a square plus b square is equal to c square. Now let's talk about areas of these semicircles. AA will be pi a square by 2, AB is pi b square by 2, and similarly AC is pi c square by 2. Now can I directly say AA plus AB is going to be equal to AC? Put the values of areas here. Pi by 2 will get cancelled from both the sides, right? And we will get AA plus AB is equal to AC. Even if this bigger semicircle is flipped upwards, the relation will hold true, right? Sum of areas of two small semicircles is equal to area of bigger semicircle. Now what would be the area of this shaded region? This is interesting. This shaded portion is nothing but two semicircles plus the right triangle minus the bigger semicircle, right? Now we use the result derived earlier. Sum of areas of smaller circles is equal to area of bigger circle. So these two will cancel each other out and the shaded portion will come out to be equal to area of triangle. Now keep this figure in mind and remember the direct result. Next, see this question. A square inscribed in a circle, and on all four sides of a square, semicircles are drawn. Find the area of the shaded region. If we bisect this figure in two, we get something familiar, right? Now for this figure, sum of shaded region is equal to area of triangle. So for whole figure, area of shaded region will be area of square. Next question. Find the area of colored region. Now this colored region is inside the triangle, right? Let's focus on the triangular part. Area of shaded region will be the complete triangle minus the empty parts, which if you look carefully can be combined to form one complete circle. Radius of this circle will be half the breadth of rectangle, that would be 10 units. Now look in the original figure. These two red colored parts are equal because the two circles are being cut in symmetrical manner. Now this figure is symmetrical about point O, and any line passing through O will cut the figure into equal halves only. So final area will be half base into height minus pi r square. The next figure we are going to dissect is square. We can cut it into 4 smaller squares, 4 smaller congruent squares, or we can cut it into 9 smaller squares. or we can cut it into 4 congruent triangles. Now don't mistake to take these triangles as equilateral. These are right triangles. Okay. We can also make 8 congruent triangles, 8 congruent right triangles, and we can divide it into a smaller square and 4 right triangles like this. Combine these two figures and we get the square dissected into 16 right triangles. There is one more way to dissect the square into 16 right triangles, 16 congruent right triangles. Look at this figure. Now I want you to pause the video and pay attention to how the cuts are made. You should be able to recall the pattern when you see a random figure like this. Find the area of the shaded region. Well, this is the construction involved. 8 out of 16 triangles are shaded. Required area will be half of the total area. Take another question. A rectangle inscribed in a square is given and we have to find what percentage of area is shaded. Now in this figure, side of square is trisected, right? The ratio is 1:2 means it is trisected. Now think of a dissection in which the sides are trisected. Here you go, 9 smaller squares. Out of these 9 small squares, 1 full square and 6 half squares are shaded. That makes a total of 4 full squares and out of 9. So the percentage will be 4 upon 9 into 100, that is 44.44. Next question, a triangle in a square. No matter how you dissect the square, the shaded triangle will not be visible in terms of smaller congruent parts. Try it. In such questions, next step in your thought process should be to look for the non-shaded area outside the triangle. Take upper half of the square, it would be a rectangle with area of 2 square units. Non-shaded empty space is half of the rectangle's area, right? That would be 1 unit. Same process can be repeated for this empty space in the left. Area is 1 unit, 1 square unit, and if we make 4 squares, area of 1 will be 1 square unit and half of which will be 0.5 square unit. This non-shaded area, right? So shaded area is total area of a square, that is 4 units, minus the non-shaded area, that is 1 plus 1 plus 0.5. So this brings the total required area to 1.5 square units. Next question. Side of bigger square is A and smaller square is B. We have to find B square upon A square. Now look at this triangle. Line bisecting a side and parallel to base bisects the third side, midpoint theorem, right? So in the triangle's third side, upper half is also B, and by same logic in this triangle, we can mark length B. Again consider the previous triangle and apply Pythagoras theorem. A square is equal to 2B whole square plus B square. A square is equal to 5B square and B square upon A square is equal to 1 by 5. Same thing can be seen when these 4 right triangles are rotated to fit like this. And in this cross-shaped figure so formed, area of central shaded region is 1 square out of 5 parts, 1 square out of 5 squares. So that would be 1 upon 5, 1/5 of the complete figure. Now this observation was on a little tougher side and it requires further proof that all these squares are congruent. So I will leave you to it. And let's move on to the next figure, rectangles. With 2 cuts, it can be divided into 4 smaller rectangles, right? Cut it diagonally and these 4 triangles will have equal area. These triangles are not congruent, but they have equal area. Why do they have equal area? Well, diagonals of a rectangle bisect each other. So for these 2 triangles, base is equal and height is also equal. Combine the two figures and we get 8 congruent triangles. That's right, 8 congruent triangles. Consider this figure as a section, this whole figure as one section, and we can divide the initial rectangle into 2 of such sections. Or we can make more such sections, right? Now let's take a question. Area of this shaded rectangle is to area of regular decagon is to be calculated. A decagon can be divided into 10 congruent triangles. So area of decagon is 10 times area of this one triangle, right? And if you look at this rectangle, its diagonal divided into 4 triangles of equal area. So area of rectangle is 4 times area of this triangle. Clearly the ratio is 4:10 or 2:5. Next question. This was asked in CAT 2002. Area of a right triangle is given and EC is 3 times the base of right triangle. So basically on EC, 3 such right triangles can be placed, right? And in the empty space, 4 more triangles can be placed upside down, making a total of 8 right triangles in this rectangle. So area of rectangle is 8 times the area of right triangle. That would be 96 centimeter square. Next question. Again, this is from CAT 2001. Area of triangle BDC is half of overall rectangle, right? And these 3 triangles have equal area as the bases are equal and the height is also same. So area of triangle BDC is 3 times the area of triangle BEF. So the ratio of triangle BEF to whole rectangle is 1:6. Next is pretty easy one. You can pause and try. Area of red region is given and area of blue region is asked. Now usually in such questions, areas are equal only. You must have noticed by now. Most of the times areas are equal, and so will be in this case. If you move these 2 smaller squares, what we get is a rectangle with a diagonal separating the red and blue area. So areas are equal, red and blue areas are equal. Next question. Not that these type of questions are likely to be asked in CAT. I am just trying to train your brain into seeing figures in different ways they could be dissected. This process will help you in solving many questions visually, just like that. So here, a point is taken on the diagonal and perpendiculars are drawn to the sides. Area of red region is given, blue is to be found out. Look at this rectangle. The 2 triangles separated by the diagonal have equal area, right? Same will be the case for this small rectangle. The 2 triangles will have equal area. Now in this bigger rectangle, the whole figure, diagonal is dividing it into 2 triangles of equal area. So A1 plus A red plus A2 will be equal to A1 plus A blue plus A2, right? A red is equal to A blue. As I said earlier, usually in such questions, areas are equal. Next, we have a parallelogram. Pick a point inside it and join it to its corners. As I said earlier, in most of such questions, the 2 areas are equal. Here also, blue region is equal to yellow region. But why? Think about it. Only logic you are going to need is diagonal of a parallelogram divides it into 2 triangles of equal area. If we make 2 cuts parallel to the sides and passing through the initial point, then we can cut the original figure into 4 smaller parallelograms. In each of these 4 figures, blue area is equal to yellow, as these areas are separated by diagonals, right? So overall, blue area is equal to yellow area. That's it for this video. In next video, we'll observe some more patterns when squares are combined with circles and when hexagons are dissected. Thank you for watching. Hey wait, watch the second part of this video at gofodu.com. There you will find more such engaging videos. We also put daily free sectional quizzes on our website. And lastly, I want you to know that I have been an average student all my life and still managed to score a 98 in CAT. I know where you will fumble and where you might get confused because I have been there. So help me help you by subscribing to this channel. You can also follow us on Instagram and Facebook where we post new concepts daily. Links are in the description. Thank you.